Good morning, everyone, and welcome to KETIV AVA. My name is Brian Mongkolpoonsuk. Thanks for joining me today, guys. I'm excited to share with you guys another, not Fusion Friday anymore, but KETIV AVA. And for those of you who are new, KETIV AVA are webinars that we do Wednesday, Thursday, and Friday of the week to go over the core Autodesk products because we here at KETIV believe knowledge should be shared. Without further ado, let's go ahead and hop into creating assemblies in Fusion 360. All right, so the purpose of the webinar today is, of course, to show you how to create assemblies, but there's also these three higher level purposes, and one of them is for time efficiency. So instead of using your time spending hours on trying to look up videos and troubleshooting yourself of creating assemblies, I'm going to show you right here in around 30 minutes of how to properly create your assemblies and the pros and cons to the habits that you may or may not already have in Fusion 360. I'm also going to show you guys how to prevent future errors. We're going to do here's how to not do it, and here's how to do it. Here's how to properly create an assembly. And essentially, if you start off with a bad foundation, it's going to catch up to you later on in your design process. So you're going to want to understand how to properly create it in the first place, so then you don't have anything biting you later down the line. And the third one is to set you up for success. We want to make sure that once you have that good foundation ready, this model is not only just easy to access, easy to edit, but you can also collaborate with other people using it. You want to make as predictable as a model as possible, and it's just going to be best for you later down the line doing it right the first time. Once again, ask those questions in the comments section of the GoToMeeting, please, and I'll be doing my best to answer them at the end. So let's hop here into Fusion and let me open up another tab, but the first tab is going to be of how not to create assemblies inside of Fusion 360. And this is assuming you guys already know or have already played around with Fusion 360, or at least at a basic level of understanding here. So first, usually when people model inside of Fusion, assembly or not assembly, they would go straight to the sketches, which I have done in the past as well, and maybe sometimes still do. But you would create your model or create your sketch, extrude it to become a body, and then they think, okay, now I need to create another body because I have multiple bodies or components, what we call in Fusion, in my design here. So I'm going to have to create another one. And they think, okay, I understand now that joints are like mates if you come from SolidWorks, and I'm going to need to use these to associate those bodies with each other, but I'm going to need to change them to components. So what people tend to do is they would create a sketch, and then when they create the 3D body, they go over here and think they can get away with just creating a new component, which is fine if you don't care about going back to edit it properly, and if you don't care about the sketches being associated with it. So now your sketch number 2 is up here in the sketches folder in the assembly workspace, whereas your component that you just created for number 2 is down below here without that sketch. And you can't just drag and drop it into here, unfortunately. I've tried that many times before to try to fix the problem, but it's essentially there forever, and it's separated. And the bad thing about this is, one, it's disorganized, and you can't see, especially if you have multiple components here, you have to scavenge through your sketches to find which one's associated with what. But also, when you go to export it, it doesn't export the sketch as well. It only exports the body. So it's as if you're sending whoever you're sending it to a dumb body without the sketches. Another way to to help find your sketches would have been to go here to component color cycling toggle. And now we're given some color coding to our components. And if we look below here, you can see that there's a green line that goes across the top, but that's supposed to be maybe blue because we want to be able to indicate that, or I mean, for this one, it's supposed to be blue because we want to be able to indicate that this sketch was created for this component 1 here. But however, since we created this sketch and everything in the assembly workspace at the assembly level, it was shown here in that level. And now we are unable to detect, that this sketch is correlated with that, even using the components cycle toggling. But if you create the right way, you will be able to detect it down below here. And we'll go ahead and hop into that now. So here's the way you're supposed to be creating assemblies inside of Fusion. Now, first and foremost, probably the best tip is to save it. Go ahead. You can go ahead up here and just save. And I would recommend, especially if it's an assembly, giving it a name that indicates that it's the assembly level. It has a lot of components in this one, so I'll call it File Cabinet Assembly. Should be pretty straightforward. And make sure whatever data panel you have open, that is going to save to that location. So if you're in a different project, maybe someone else's project, and you don't tend to be in it, make sure that you browse to that location. But I'm in the correct one in this case. So now that was step number 1. Step number 2 is to create a new component. And you want to create a new component for each part that's going to exist in your assembly. And you can always start working on it and then create new ones later down the line. But I like to create the ones you know that you're going to make right off the bat. So you kind of have a top-down design mentality. So to do that, instead of just going straight to a sketch, go here to Assemble, then go to New Component. Now I know my file cabinet here is going to have a base and 2 doors. So I'm going to name the first one base. And it's going to be an empty component. I'm not going to activate it yet, and I'll show you what that is in a second. And it's not a sheet metal component, so I'm not going to select that. And this is one of the file cabinets here in the office that I measured. So hopefully it looks good here in the in Fusion. So I created base 1. I didn't activate it, so it's still empty. And I'll show you what that means in a second. And I know I have 2 other components. They're the doors to the file cabinet. So I'm going to create another new component. Call it door 1. I won't activate that as well. And then one last one as door 2. Trying to make it as easy to understand as possible for not only myself, but other users as well. So now, if I want to start creating my base, I'm not going to just start sketching. I want to make sure I activate base 1. Now what activating does, and I just clicked on this white circle right there to put that black dot in the middle of it. What activating does is it makes whatever I do from this point forward, whether it's sketches, extrusions, even construction planes, they will all be stored in my base container here. And that's what I like to call components. I like to think of them as containers. Now you can put even components in other components as well. Like this is actually considered a component with these 3 base door components in them. So essentially activating this, now whatever I do will be stored inside of base 1. Whereas before we were always at the top level assembly component, and everything we did was stored in there. And that's why when we created components down here later, it was a little messy. So let's go ahead and activate base 1. And now let's start creating our file cabinet. And this file cabinet was 84 by 36. And it was about 1 inch thick. And I'm going to leave the color component cycle toggling, which is why it's red or pink, if you will, on until I prove my point here. So next, so now, okay, I created the sketch and the extrusion, both red, not orange like it is at the top level assembly here. And both the bodies and the sketches are located under base. So not only is it organized here at the design history level, but it's also organized here at the browser level. So I'm almost done here with the model. I'm activating base 1 again. Going to do one more maneuver to it. Once again, the sketch and the extrusion I want to be associated with base 1 is inside of base 1. I can even rename it if I wanted to. Like I can call this the offset of, you know, the file cabinet or of the back or something like that. So now I'm done with base 1. I can move on to door number 1 and activate that, and then everything I do will be stored in door number 1. Notice how when I access door number 1, it makes the other bodies and components transparent. So I can still use it as reference, but it tells me that, hey, you're not focusing in that component anymore. You're now in a different component. So I'm using, just like I said, I'm going to use it as reference to create my first door. So that's door number 1. And then I'll hop over to door number 2 and do the same thing. And that's door number 2. Now let's hop out of all these components and go to the top level assembly. And now we can see that the base, the door number 1, door number 2 is all done. If you look here at the bottom, they're all organized in respect to the colors and the design history, as well as over here in the browser. And if I turn the component color cycling toggle off, I think I proved my point there. Now we can still see it down below here. Not as easy to spot it, but if you always want to go back to spot it, you know where to find it now. But these are at least still organized here, so you know where to grab your sketches and bodies and things like that. So now let's go ahead and bring in the door handles to open our file cabinet here. And to do that, we would be bringing in a component that's saved inside of the data panel here. And you can also save McMaster-Carr components, which you can get from the insert tool there. You can insert vices that you can get from the data panel, which I'll show you at the end here. But if you already have a part like I do here for my handle, I'll go ahead and get that. And I'll right-click on it and insert it into my current design. So that's one, and I'm going to bring in another one for the other door. And that's 2. So for those of you who aren't too familiar with inserting into current design, the component that does come in comes in with this link. And what this link means is that you can't edit this model that you brought in until you break that link, because it's associated with this component here in the data panel. So whatever you edit here in the data panel will update and update your model here in the assembly. But if you right click and hit break link, it will get rid of that associativity. But just keep in mind, if you break that link, that associativity goes away forever. So for now, I'll leave that link. And now we have all the components that we need to get started with joining them together or associating these components together, since they're not bodies anymore, or they never technically were, associated them together because right now they're floating in space like this, and we want them to kind of behave in the way we'd expect it to behave. So first off, since they're all floating in space, what we want to do is ground one of them, and the most practical one to ground would probably be the base. So what we can do is right click and hit ground. Now it's indicated by this orange thumbtack that we cannot move this piece. Next, we want to make these doors behave realistically in respect to the file cabinet here. And we can use joints. Now joints are located here, and they position the components relative to one another. So whether you want it to be glued to something, you want it to revolve like it's swiveled around something, however you would expect it to behave in real life can be achieved by using joints. And since these are components, you can use these joints. So go ahead and hit joint. It's asking me, since I moved this door, do you want to capture the current position that it's in now or continue in the previous position? So if I hit continue, this door will go back to where it originally was, which is fine. In this case, I want to show you a different type of joint as well. So I'm going to actually hit capture position and show you how to create a joint if your door was always away from the cabinet here. So for these joints, we use these, I like to call them happy faces. They kind of look like happy faces to me, where you can select on one component where it would, where the joint would behave in respect to the other one. So I selected one on there, and I'm going to select this one on the base here. And it gives you a little preview of what that's going to look like. And if the preview stopped too soon for you, just go ahead and animate that again. So essentially, it's really important where you select your joints, and it takes a little bit of getting used to. So then you know how it behaves later down the line. But yeah, there's a bunch of different other types you can choose from. You can do a rigid one, which kind of glues it to the model. And there's slider, cylindrical, ball even. But in this case, we're going to do a revolute. So now that we have the revolute done, now it's behaving as what we would expect it to behave. However, if I do bring it a little bit too far past its point here where it overlaps with the model, we don't want that. That's not something realistic that we would see that we would expect from a real life model. So to fix that, we can either turn on contacts by going under Assemble to enable all contacts. So now whenever it makes contact with another 3D body, it will stop. Or I'm going to turn off the contact. We can turn on joint limits. Now, if you see this 124 degrees sign here, when I turn it to about this location here, it's telling me that's at 0. And when I open it to this location here, it's around 180. So now I know the joint limits. So I know that if I go here and I right click the joint here in the design history and I do edit joint limits, the minimum was 0 degrees and the maximum that it could open was 180 degrees. So this could be one of the options you can use to realistically create your joints. So now if I close it there, close at 0 and stops at 180. Now we can do the same thing here onto the other side as well. Except on this side, instead of using joints, we are going to use joints, but they're called as-built joints. And since I didn't move this second door, I'm going to capture the position, or sorry, continue. So in case I did move it a little bit, but since this is where I want it to be, I can use as-built joints and just select the component itself instead of selecting that little corner. Select the second component, and now I could choose where it's jointed about, if that makes sense, where it's going to pivot about in this case. So as-built joints, if your assembly parts are already connected and built, you just need to, like a step file if you bring in, for example, you just need to create joints like that. You can just use as-built joints, and it's a lot quicker than using the regular joint tool. So I'll go ahead and animate that one more time just to double check that it's revolving the way I want it to. And then I can create the joint limits. And you can create joint limits by right-clicking on the joint itself. You can right-click on it down below here, or you can right-click on it here in the browser history, or the browser bar. So I believe it was 0 and 180. And now it's behaving the way like the other door is behaving. So now we want to connect the door handles to this. And to connect the door handles, we're going to use joint origin. And what a joint origin is, I like to describe it as like a Velcro. So in this case, we want to turn on the joint origin Velcros for my door handles, which are these guys right here. The happy faces are back. And now we're going to want to create the Velcros that exist around this area, these areas of the door where you would expect the door handle to be. And to do that, we'll go ahead and go into one of the doors. So I'll go ahead and activate door number 1. Going about 15 inches. And there's more than one way you can definitely do this, guys. This is just the way I found easiest. And I'm creating a sketch in here that will allow me to place a joint origin in one of those Velcros, so then I can kind of patch them together or Velcro them together. So there's the joint origin tool, and I'll place it right there where that sketch was. So now I can Velcro this and this handle and this location over here together. And I'll go ahead and do the same for door number 2. I'll activate door number 2. And I will create the sketch or offset the plane. And this time I won't need to create a joint origin per se. I just wanted to show you the first one as an example. Sometimes they automatically show while you are working with joints, but in this case, we at least need to create that sketch to reference where we want it to be. So now we can just use the joint tool and simply click on the first, click on the second. Don't make it revolve around it. And now we have number 1. And we'll hide these sketches later to show visibility, but joint number 2, that symbol or that joint origin, that location, notice how there was no joint origin there. I just referenced the sketch that existed and hit OK. Now I'll go ahead and hide the sketches. And it's good practice to hide the sketch itself rather than the sketch folder, because if you are working inside like door number 1 or door number 2 and you hit the sketch folder and you created a sketch while you're in there and you don't know where the sketch went, it's probably because you turned off the entire folder. So I like to turn off just the join or the sketch or the whatever you're trying to turn off, the actual one itself instead of the folder. Looks like there's one more origin left to hide. If you click on it, it can underline where it's located. So there it is right there. So I'm going to hide that one just to make it look better here. And now let's test it. So that should work accordingly, and that should work accordingly. Awesome. And there's multiple different ways you can create this assembly. You could have used rigid groups, for example, to made the door handle rigid with the door itself, and make them swing open instead of like maybe joints, depending on your preference and or the way the assembly was created initially. All right, and then of course it's always good to do your model justice by bringing it into a render workspace, adding some appearances to it. And then giving it a nice render. And then of course we have a video on rendering on YouTube as well. If you want to learn how to render inside of Fusion, it's free. Unless you do it on the cloud, then it'll cost you cloud credits, but you can do it locally like I am here. And yeah, we have a whole video on that that explains you how to create these high quality images of your model. So one more thing I wanted to show you guys was the devices, because I know a lot of you guys use Fusion for CAM, and some of you guys may not know that there are these, if you go to your data panel, there are these CAM samples, and if you have a common work holding, kind of like there's a lot of different ones here, for like Chick, for example, you can either go to the website and you can go to a product and download it. Download it from, let's see if there's a download. You can download a step file from here to bring into Fusion. You would have to create the joints and things like that, and that'll be really useful for when you create your tool paths around your part. You can see if it might crash into your vise, and it's also looks really good to show your colleagues, to show your boss, to show your customers that what it looks like while you're creating tool paths in there. Or if you can find it here in CAM samples first, I'd recommend doing that, because then it already has some joints for you. So that's already an extra step, and you can just place your raw material there, and then you can start creating your tool paths. I would recommend saving this locally first, the vise, and then while you're in an assembly like this, you would right click and insert into your current design. So then you're not editing the vise or editing the model itself. It's its own component coming in separately that's linked that you can't really touch. So just another advice that I have for people working with vices like that. All right. So if you guys have had any questions or have any questions about creating assemblies in Fusion, feel free to comment it in right now or write down my email, and you can definitely email me later. I'm very passionate about using Fusion, not only for work, but also for recreational activities at home as well. So anything Fusion, I would love to talk to you guys about. So let's see if we have any questions over here. We have one from Josh. He's asking, how is the data stored locally in the Fusion 360 data panel? So in the data panel, Josh, the data is stored. One is stored on the cloud. When you hit save, it's stored once on the cloud, and one is locally, not on your hard drive per se, is more on the software. So let's go over here to Fusion real quick. So if we hit save, we can see that it's saved over here on the left-hand side for, if we go here to preferences, for this number of days. So if you go to your preferences, I changed mine to 120. I wanted to see it there longer because why not? I want to have more longer access to my data. So that's about, what was it? 4 months right there. So if you edited or saved your file within the 4 months, then, or the number of days, then you will have access to your file inside of Fusion, whether you're online or offline. But if it's past the 4 months, then you would have to go back online, and then you'd have to cache it locally or edit it or save it or do something to it so then you can have access to it while you're offline. But if you want to save it locally to like a C drive or something, that would be a different maneuver. It'd be more like an export maneuver there that you'd want to do. The Fusion's main purpose is to work with the cloud and work online. So if you do want to save it locally, yeah, it would be the export method. But if you want to save it, online, or if it's better to work with the cloud and just extend the cache time period of days here, because usually it's reconnected to the internet every time you turn on your computer. Thanks again for watching. Look forward to see you guys at the next one.